Section 2 about circles. So looking at circles, we have to have a center. So we have a center and a radius. Okay, and then there's two different forms. There's center radius form, which I'll discuss first. And then there's a general form. Okay, which I'll discuss second. Okay, so that means we have a center. We're going to let this center be HK. Well, all centers for circles are HK, H comma K, kind of similar to your vertex center of a quadratic. And then our radius would be R. And then the definition of a circle is we have from a center point, all the points around the edge are equal distance from the center, right? So that's a circle. Radius R. And then the equation for the center radius form is x minus h quantity squared plus y minus k quantity squared equals r squared. So remember, those are squared, right? So this is our radius squared. So if I actually want to find my radius, I would have to square root that number. And also remember, we have negative h here and negative k would be my center. You can kind of think about it as opposite of what's in there, because my center is hk, but if it's say x plus 2, then I take the opposite, or you could say negative h. So my center would be negative 2 for my x value, quantity squared, and then say plus y minus 3 quantity squared equals 16. So then my center would be negative 2, 3, because I take the opposite of what's in there. So I'm taking the opposites of what's in there. Okay, and then r squared, to find r, I have to square root that, right? So I have to square root 16. So r is equal to 4. It's plus or minus, but since radius is a distance, it's going to be the positive of that root. Okay? So what we currently have in our equation is a negative h and a negative k. What we want is positive h, k for our center, right? So that means opposite of h, opposite of k. So it's the opposite of what's in these two. And then what you have is r squared. You want r, so that means you're going to have to square root that r squared to get your radius. Alright, so here's some problems. We want to write the equation, right, of the circle. So as long as it doesn't say general form, then we just use this form. X minus h quantity squared plus y minus k quantity squared equals r squared. So here they give us a center and the radius. So we're just plugging in these h and our k, but it's negative h and negative k. This is h, this is k, this is r. So I'm plugging in negative h, so that's opposite of h. So opposite of negative 3 is a positive 3, quantity squared. Opposite of 4 is a negative 4, quantity squared. And our radius squared, so that means I got to take 6 and square it. So then I get 36. So the circle radius form, which if they just ask you to write an equation for the circle, you can use this form unless they state they want it in general form. So x plus 3 quantity squared plus y minus 4 quantity squared equals 36. And then if we were actually to, you don't have to do this unless they ask for the general form, but if we squared this and squared this and then set it equal to 0, we would get our general form. So we'd get x squared plus 6x plus 9 for x plus 3 quantity squared, and then I'm adding y minus 4 quantity squared, which is a y squared minus 8y plus 16 equals 36. Then instead it equals 0, combine like terms. And you always put x squared first, followed by whatever your y squared is. It's always going to be positive here. And then we have a negative 6x, so plus 6x. Then a negative 8y, and then 9 and 16 is 25, equals 36. But if I want it in general form, then I need to move over this 36, and I can only take it away from the 25 there. So this would be the general form of that same equation. So based on what they ask for, that's what they're looking for. Whether center radius form, or if they just say write the equation for a circle. So unless they say write the general form, then you can just go with the other one, the circle radius form, or the circle radius form, or center radius form actually. So this is general form. Okay, now if we were asked to graph circles, then we're looking at the equation either general form or the center radius form, and asked to graph it. So first we have to find our center and our radius. So we want to make sure that we have a quantity squared, right? We have a plus in between these two quantity squareds, and then it equals some number, right? So this is the kind of form that we want it to look like. So since we're after our center h comma k, and what's inside here is negative h, negative k. Alright, what's inside here is negative h, negative k. We want to do the opposite. So what's the opposite of positive 3? Well, that's negative 3. What's opposite of negative 4? That's positive 4. So there's my center. And I go ahead and graph that on an xy plane. So I move over negative 3, 2, 3, and I go up 4, 1, 2, 3, 4. So there's my center at negative 3, 4. And now I find my radius by taking this number that the sum of those squareds are equal to. Take that number and I square root it, right? Because it was r squared, but I want r, so I'd have to square root that. And I only care about the positive here because it's the radius, the distance, so that equals 6, so r equals 6. So from the center, don't go from the origin, but from the center, I'm going to count down 6. So 1, 2, I'm going off of this line, right? 1, 2, 3, 4, 5, 6. So right here, right? Then I go to the right 6, going off the x-axis here. 1, 2, 3, 4, 5, 6, up 6. So from this point, 1, 2, 3, 4, 5, 6. And then to the left 6. 1, 2, 3, 4, 5, 6. And now I try to draw the best circle that I can. It's okay, it's off. But I do want these points because I'm going to be looking how far is this from here to here? How far is it from here to here? How far is it from here to here and here to here? And it should be equal distance because that's the definition of a circle, right? We're at some center point and every point along the edge is equal distance from that center, right? So there would be the answer to this graph. Go ahead and try this one. How about you graph this one? X minus 2 quantity squared plus y plus 7 quantity squared equals 8. Right? So since it equals 8, you might going to have to take the square root of 8, right? So you might have to get out a calculator and do that and then estimate, you know, if it's 2 point, which it's 2 point something, 2.8 or 2.7, you'd go over 2 and then almost all the way to another point, right, when you're actually graphing that circle. Okay, so go ahead and try that. Go ahead and pause the video and then I'll give you the answer to it. So our center, we want to start there, is opposite of this, which is positive 2, opposite of 7, which is negative 7, and then our radius is the square root of that number, which is 8. So sometimes it might be set equal to 0 and that 8 might be over here, so then you need to subtract on both sides by it to get it, because we want to set it equal to x minus h quantity squared plus y, or y minus k quantity squared. So you might have to move some number over here. Okay. Another thing that you might have, and then you can graph this. Another thing you might have is maybe this is, say, divided by 2, and this is divided by 3. So we don't want fractions, right? Our original standard equation doesn't have fractions. So how would I get rid of that? Well, multiply by the least common multiple, right, on all these terms. So if I multiply by 6, well, if I multiply by 6, then that gets rid of this, and this becomes a 3. If I multiply by 6 here, that gets rid of the 3, and gets rid of that. This is, and then I have to multiply this by 6. But you're not going to have a problem like that, so I'm not going to worry about that, because you won't have a problem like that, and that's kind of, you wouldn't have a problem like that. So the way that I was doing anyways wouldn't get rid of your, you'd have to get rid of your fractions, but then you add numbers out front, and they wouldn't really, you would just keep on going back and forth, so you won't have a problem like that, so don't worry about that. So just go ahead and graph that center and that radius, because when you do have a problem like that, we're not looking at circles anymore. We're looking at ellipses, and we'll talk about that next time. So don't worry about these type of problems if it's divided by something, because those aren't circles, those are ellipses, and we'll get into that next time. Okay, so if we were to graph that, we'd go over 2, and then go down 7. 1, 2, 3, 4, 5, 6, 7. So that would be our center, 2, -7. And then we'd use our radius, which is square root of 8, which is about 2.8-ish. So we'd go over 2, and then almost 3 from there, so about right here. Then we'd go up 2, 1, 2, and a little bit more. Left 2, 1, 2, and a little bit more. Down 2, 1, 2, and a little bit more. And that would be our circle, which is terrible looking, but that's what it would be. Okay, looking at the general form, or another term is called unfactored form. So on the test it might say general form, or it might say factored form, or the homework might go from both back and forth here. Unfactored form to general form, right? Factored form means what times what equals that. That's why it's quantity squared, because it's two things being multiplied, two factors. Okay, so the general form is ax squared plus bx, or by squared plus cx plus dx, that's not a parenthesis, that is an x, plus e is equal to 0. So a, b, c, d, and e are all just numbers, right? They can be any numbers. And then we're just working through these, and so that is the general form of a circle. So that's what the general form of a circle looks like. You can get there from, if you already have circle radius form, all you have to do is just square those binomials, move that radius squared over, combine like terms, and you'll have your general form or unfactored form. So here's a problem that is in factored form or general form, and we want to put it in center radius form by using completing the square, and we're going to have to do completing the square twice, right? So I want to put my x's, everything that has an x on one side, everything that has a y, not on two sides, but leave a space here for your c. And then on this side put your y's, it's really on the same side, plus 10y, and then plus 25 equals 0. So first of all, I want to move this 25 over, this re, when it was in factored form, and then I'm going to leave a space here, and you are going to be adding something there, and then plus y squared plus 10y, leave another space, and you can put a plus here because it's going to be a plus, and then minus 25. Okay, so you're going to do completing the square twice, right? We're going to do some side work. We're going to take our b's, -6 and 10, and we're going to divide them by 2, and then we're going to square them. And that's what we're going to add to these spots right here, and we have to add it to this side, right? Okay, so -3 or -6 divided by 2 is -3. -3 squared is a 9, so I'm going to add 9 here, and I'm going to add 9 here. Then I'm going to take my 10 divided by 2 and square it, and I get 25. So I'm going to add 25 here, and I'm going to add 25 here. Okay, then I'm going to simplify, and I'm going to factor this quadratic of the x and this of the y, and then simplify this right side. So simplify the right side is 9, because negative 25 and 25 cancel out. I factor this, which is nice, right, because it's a perfect square trinomial. Is going to factor to my x minus my b over 2, which was 3 quantity squared, and then I'm adding. Factor my y squared here, which is going to be y. It's going to be my b over 2 from this quadratic, which was 10 over 2, which is 5, so plus 5 quantity squared equals 9. And now it's in center radius form. So you wrote it in center radius form, and we're all done. Okay, and then you can label, then you could find your center. So here, if they ask you to graph a formula or equation that looks like this, you would have to do center radius form first. Then you could go ahead and find your center, which for this problem, remember, it's always your x is opposite of this, so 3, and your y is opposite of this, which is negative 5. So there's your center. And then to find your radius, oops, whoa, dancing there. To find your radius, we would just take that, what it's equal to, 9, and square root it. And we're always looking at the positive one, so our radius r would be 3. And then you could graph this. Go over 3, 1, 2, 3, go down 5, 4, 5. Graph that point, there's your center. At 3, negative 5. And then I could go over 3, 1, 2, 3. I could go down 3, 1, 2, 3. I could go left 3, and then up 3, 1, 2, 3. And draw my circle. So here's another problem. I want you to go ahead and try this one on your own. Don't pause it yet, because I'm going to tell you something that you have to do first, right? Because whenever we complete the square, so we want to put this in center radius form first, and then go ahead and graph it. But when we do completing square, our a has to be 1. Well, in this one, our a and our b have to be 1. So I need to divide everything by the least common multiple of my a and my b here, which is 2. Right? So I divide everything by 2, including that 1 on the other side. And then you can go ahead and start this problem. Okay, so now you can go start this problem, pause the video, and go ahead. Alright, I'm going to start working on it. Here we go. So I want to put my x's together, everything with an x together, and then leave a space for your new c, and then add all your y's, stuff that has y in it, and leave a space. Okay, so last time it was already set equal to 0, so I didn't need to move anything this time because it wasn't set equal to 0. So we're good here. Now we're going to go ahead and do some scratch work. We're going to take our b's and divide them by 2 and square it. So there we get negative 3/2 squared would be a positive, and it's always going to be positive, so you can really put a positive here every time. And then under this, you're always going to be adding here. So here we can go ahead, we get 9/4, right? Because I just take negative 3 times negative 3 and 2 times 2. So I got to add 9/4 on this over here. And then this one, our second b is 5, so 5 over 2 quantity squared, so that's 25 over 4. So 25 over 4, 25 over 4. So now if I just switch this 1/2 to 2/4, then I have a common denominator on these, and I can add them all together. So we get 2 and 9 is 11, 11 and 25 is 36. Hey, that seems pretty nice, because I know those are perfect squares, right? And eventually, aren't I going to have to, well, eventually I'll have to square root to find my r, right? So that's kind of nice. And then I can factor this side, which is, it looks complicated, but remember, it's just y, and then plus your b over 2. What was your b over 2? Wasn't that a positive 5 over 2? And then quantity squared, and then add factor of your x squared here. Well, it looks complicated, but you don't have to worry about it. I mean, it's just your x over your b over 2, or x plus your b over 2. My b over 2 is negative 3/2. Just quantity square that. You can put that negative just right here. So then there it is, right there. their center radius form. So you could find your center, which is opposite of the number with x, which is 3 over 2 would be your x, and then opposite of positive 5 halves is negative 5 halves, and your radius would be the square root of 36 over 4, which would be the square root of 36, which is 6, and the square root of 4, which is 2, so that is equal 3. So there you go. So you got your center and you got your radius. I mean, I could have simplified this to begin with and got 9 and then square rooted it, but I have to make things complicated, right? That's what teachers do. Okay, so here you go on page 185, and here are your problems, 3 through 11, 3 through 17, and 21 through 13. This is from an old thing, so I assigned some Khan Academy problems to it. So if you want to, you could write down these Khan Academy things and practice them on Khan Academy if you want extra practice, but I'm sure you guys have probably better things to do, right? So you don't have to pay attention to that Khan Academy stuff unless you want extra practice, which is nice. But you can work on those page numbers together in groups, whatever you want to do. You can watch this video time and time again. But you have center radius form, and you have general form or unfactored form. And then the center is always the opposite of the number with x and the opposite of the number with y. And then your radius, make sure you have the square root that what it's equal to find your radius. Okay, that's it.